Hello guys, sorry I've not been around for a while, had a couple of holidays and then a freelancer's job, so we're back. So we're going to pick up where we did the making monsters, and we created a USD asset from some nomad sculpts, and we made a couple of geometry variants and material variants. I mentioned in the previous tutorial that we're just going to start to do things with the assets. So we're going to do things like emitting it from Vellum. We can choose any solver, but we'll just use Vellum. So I'd like to take the USD asset and then make loads of them, and then emit them from Vellum, and then bring them back into Solaris so we can see the proxy and the render purpose and things like that. So these are a couple of renders that I have been just playing around with. So these have gone through Nuke and then DaVinci Resolve, and they're nothing special. The setup's fairly straightforward, but it's more about the workflow. So I think this tutorial will be about that. So we're going to be looking at that. So without further ado, we'll dive into Houdini. So it's a bit of a sandbox scene for me at the moment. So from the top, we've added a camera. Now if you look, we're in the stage. We'll just make sure this link is viewed like so. So we've just got a camera, and then I bring in that USD asset. Now if you remember, we published a USD asset in the previous project, and I just copied the USD asset over to my new monsters project into assets here, a monster, and it's there. So this is the USD data that is being read in here. So this contains all the wrap files, and we did all this in the previous tutorial. So we have this, so we got this little guy, and we're looking at the proxy purpose of a particular variant, the default variant that was set up. So I think it was monster C, and we can check that because we will have, interestingly enough, why don't they make that one of the defaults and that one of the defaults? So we have the monster geometry variant C, and then the last material, because for every variant there is a material variant. So this is just a rough proxy version. You can see we've got the thickness of these slightly lighter pink, and then we've got a fascia inside. So we should still be able to hide and see. If we do it on the proxy, we could hide the skin, and you can see we've got this low res view here as well. So this is the monster that we ended up doing. So just remind you, we'll do a lineup. So I'll just do a lineup and let Houdini load up all of these geometry variants, and it will apply the textures to it as well. So we essentially took three sculpts. We took this guy, and this guy from Nomad Sculpt on the iPad and put it into Houdini and made three material variants for him, three material variants for him, and three material variants for him. And then we posed this guy became this guy, and this guy became this guy. So we got like some geometry variants here, all within this one USD asset. So what we'll do is we'll pick this guy, and this guy, and we'll throw that into a Houdini Vellum setup, and then we'll export that so that we can essentially see in Solaris a really quick representation of our simulation in a proxy way. So what I'll quickly do is I'll configure a save layer, because I'm going to take this and I'm going to explore the variants. So this is a viewer. I'm just using this to show you guys what we've got. And then I'm going to explore the variants. And what I've done here is I've got the variant set Geo, because that's kind of what this variant set is called, Geo. And I'm just basically saying, give me the ones that I want, A, B, C. So you can do like star, hat, star underscore pose, and explore the variants like that, just to get a library of assets. So there are other ways of doing this, but that was quite a nice way. And then I'm going to save all that into an asset collection called assets. So the collections will now be, it's like a little shortcut here. It will save everything to do with all of this. So I'll get the proxy skin, the proxy fascia, and the render skin, render fascia for every single one, as you can see in there, which could be quite useful. And then, might sound a bit weird, but I'm going to hide the source, and I'm going to add a camera back in. So we've now got a little scene and a camera. So if you look at the camera, we see nothing. So I've got a little controller here, which is going to feed tons of stuff because I've got lots of different examples to go through. Some are the same, just slightly more emission settings on there. And I'm viewing the show selected. So I can, when I select this, I can go view show for selected. I can see where this has been used. So this is that little controller again, just to help me grab the location, consistent location. This is probably going to change with the new USD shot shot workflows, the shot load, shot pattern, shot split, and all these things. I'm going to be looking into these because they look quite handy, because I've got my own little way of working on small projects, but this is really just a sandbox project. So what I'm going to do is, in this little network box here is basically the whole setup. So you'll notice I've got a fetch node bringing in this. So all that's doing is fetching in this over here. I mean, I could really, just for the sake of this, just plug that in there because it's not really going to be too messy. And then I'm going to fetch the assets here as well, like so. So again, you don't need to have the fetch node. It's just I sometimes fetch things over, like you'll see I'm fetching it over here, and it saves me having loads of lines and things. And you'll see why later on. So we're going to fetch this in, and then what we're essentially going to do is run this. I'm going to quickly run through this really quickly. We're going to do a SOP modify. Now, if I view the SOP modify, you will see that we have what appears to be lots of creatures now that have appeared. And inside of that, we have the proxy and the render. We have new models. So if I can show this, you should be able to see me highlighting particular ones like so. So that's basically what we've done. So we've taken those three, and then we've kind of done a simulation. So if I scroll through this now, it'll read this in here. You'll notice it's not very quick, even though we are viewing a proxy version of this. If I try to press play, this is reading the back end of all of this. Now, don't worry about all of this too much at the moment. It's really just reading this. It's reading this output here, like so. So if I just hide everything here and press play, it's going to try to read all of this geometry. And Houdini is not very efficient for loading this geometry in. So this geometry is a combination. Each piece of geometry for this monster here contains a proxy version and a render version. Okay, so just so you know, we're bringing all the render geometry that we've simulated here, and we save that along with the proxy version here, which will be a little bit lighter to read, but it's still quite slow to read. And we're going to bring that all together as one BGO sequence. So Houdini is currently reading this here like so. So what I'm going to do is try to use the Geometry Clip Sequence to make this a little bit smoother. So because this is quite a heavy, well, I don't know, maybe it'll work. But what we'll essentially end up with is we'll bring in the original hierarchy here, like so. If you can see, we've got this like so here. And then we will reference in, now this might slow my machine down because when you select this Geometry Clip Sequence, it tries to like load all of the geometry you're feeding it. So we'll be feeding a BGO sequence from disk, which was provided from here into here. And what it's going to do is it's going to be a more efficient way of applying animation values to the geometry. Okay, just before I selected that, I remembered I thought it'd be useful to add a set frame range node here. So before I go into any simulation, I want to just set up a frame range for this particular test. So all I did was set up a configure layer and set this to 950 and 1100. And then with this enabled here, my stage will update to be the right length. And then I can use this value here in the geometry clip sequence, and I can say start at frame here and I can end it here. I'm always going to be 950, so I didn't have to change anything. This is just $F start, which is just evaluating the first frame of your timeline. But then the end frame, I'm actually referencing the end frame from here. So it's just going to always read the end frame. And then in Vellum, inside of this node, I'm going to make sure I do the same frame range as well. So what you'll end up with from within this node, you'll end up with originally we'll take the 3 pieces of geometry and we'll copy them onto an emission point, and we'll emit, or we'll just simulate a lot of them. So they'll come crashing down like so, and they'll all be named. So all the geometry A guys will be named like this. So originally it's fascia, and the original guy is hidden. So it's a little bit hard to see. The original guy is hidden because we did the hide up here, so he's not going to be sat at the origin. And then all of his friends come along for the journey here. We can have the render skin and the render fascia inside. Now with the proxy, I'm only showing the outside because it's just a viewport thing, and I'll talk about all this in more detail. So we'll have a collection of A's, B and C's, all named correctly, coming from this one little setup, and it's all happening in here. So we'll get into this in a sec, but just to show you, like as an overview, we're going to bring in the original hierarchy. So I really could have just had a noodle connected to this, and then this geometry clip sequence is quite it's not the easiest thing to understand. I'm still chewing through this. I mean, I keep going through this over and over again. But from my understanding, it's the efficient way of bringing in BGO sequences into USD in the correct way, and it's very good at handling. In our case, the geometry here, if I just deselect, it contains, for each one of these, it contains a render geometry, as you can see, and a proxy geometry. Okay. So the viewport has the proxy geometry, and then render time it switches over. And it's not very efficient to play because it's trying to play this through Houdini, even though this is literally just inside of here, at the end of this entire like Vellum setup and this emission setup here. It's just reading in this. It's still not very efficient. And we'll go through this in just a second. So what we have to do is plug in give it the primitive path monster var monsters, which is this, and the clip primitive path. If I middle click, it's just, I've just right click here, copy it, and I've pasted it here. It seems to work. I've left this at default, and then the start frame is $F start, and then the end frame is defined by this guy up here, and then you have to give this, I'm going to flatten this clip file, and all the clip files have matching scene graph structure is on. So this is a good way of bringing in fluid simulations, or if you've got a lot of geometry. Now this geometry is a consistent point count. If you look here, nothing's been emitted. It's just generating this SOP modify node within this is generating these guys, and they exist from frame 1. It's the same to the very last frame. It's the same. So they're just point movement, point deformations. But I do have situations sometimes where I omit them in as well, and the clip geometry sequence, the geometry clip sequence node is very good for handling this. So when it's set up, you want to load the clip file. So this wants a BGO sequence. So all I've done is I've gone inside and I've taken this node here. Now to get the path from here, you just go to advanced and you grab the full path. This is what this node is evaluating out. So you can right click, copy this parameter, press U, and then you can right click in here and paste relative reference in here like so. Now you may have seen in some tutorials that people have like an expression as well at the end of the sequence, because This node needs this magical thing added after the BGO file. It needs this SDF format args. That needs to be on the geometry sequence here if you do not use a USD configure node here. So because I've actually selected something here which is going to force the point deformation to go through each one. Very efficient. So if you just add this here and bake this out, which we'll talk about in a little while, you won't need to add any expressions to this. So I get away with that here. So in terms of this, it's going to create a clip file per frame in this location, and then it's going to create a manifest and topology. So again, these are what make this node really efficient. So once you set all this up, and these paths are actually, if you click on here, you'll see that this node is driving these paths, and I'm just kind of making sure they go to somewhere sensible. So I can kind of copy and paste this, and it'll always be in its own location. So you can play around with the scene and see where that's going to in my project structure. You can see it's gone into this monster drop project, shots, and the shot 000, because I haven't really bothered about a shot at the moment. Monster molt is just what I'm calling this setup, and I'm just printing USD version 1. So all of these get, like, it's a unique folder named after this, so I can have multiple setups, and I can basically take the master setup here, oops, and just drive a load of different versions of the simulation, because I might have different versions and stuff here. So we'll get into all of this. It's very repetitive, so it's just kind of getting your head around this bit, I guess, for now. But you'll notice now, if you try to press play in the SOP context, it's really slow, and it's going to be a pain for like lighting and rendering and stuff. So if you add it to the geometry clip sequence, this will pause Houdini for a long time, depending on how long your sequence is, how much data you've got. But it's going to utilize this folder, and when you save this out, it's going to save this to disk. But until then, it's going to put this into your RAM. It's going to be kind of really quick to see where we are. So we can actually come here and look at this geometry clip sequence like so. But the thing is, if you close Houdini and reload, when you click on this again, it's going to hang for ages and take up your resources, I believe, before you can get to this point. So I've added a cache node here, and again, it's $F start, and then the actual end frame is linked to this. So these belong together in terms of the range. And then I will cache this out. Oops, I don't know why that's reloading. Let me see if I can. And this is a bit weird, because it sometimes triggers it to kind of just reload, and I don't really know why, what it's doing. It does my nut in, to be honest. But if I just kind of press escape, we should be able to get, or maybe there's no cache on disk. It looks like it's going to try to reevaluate all this from scratch, which these are actually have already been cached here. So it forces these files to be saved to disk. So you'll see that if I go to the project monster drop and I save this in shots, and then shot 0, and then monster molt data, I'm going to class it as CFX. I think in this node I class this as CFX. I can't interact with Houdini while it's doing this. But yeah, it's CFX and it's USD data. And I've just started throwing everything in there. So this monster molt clipper 1 is this guy, and then the cache is here. I could be a bit more organized, but the cache is going to be a really small file that just references what's inside of here, and you'll have a per frame clip sequence, USD clip sequence, USDC clip sequence, accompanied by a manifest and a topology file. and that's what it's going to read. And you're essentially doubling your data now. So you've actually done a Vellum sim, and perhaps you've saved that out as a BGO sequence, so you've saved your simulation geometry out. Then you would need to wrap your render geometry, or point deform your render geometry to the simulation, and then create a proxy geometry for the viewport as well to kind of comply with the whole USD thing. It's up to you really if you want to do all this, because you might just be working in tests and stuff, but I was just I wanted to load this up a following day and not have this constantly evaluate, or this to be, or without this setup, have this really slow. Because back in the day, I think we would have probably just had this in the object level and just loaded it in, and it would have been quite slow. And you would have probably saved out the high res to disk and then had a delayed load using the proxy in the viewport maybe. So this is kind of recreating that in a USD way, I guess. So this is what these files are. So again, you're now having to do a simulation and then wrap the render geo and the render proxy to disk in a BGO sequence that gets brought in and converted into these bite-sized USD chunks. That goes back into the hierarchy, back into the USD world. So you kind of create stuff on the stage, then you go into Houdini and you kind of generate more data, and you try to make sure it goes back into the USD hierarchy, and then you publish it for the next department to load up somehow. But it's just me, so I normally tend to keep my work in one Houdini session or anything like that. So I would love to see this done professionally, to be honest, because it's quite new, the concept of it to me, and it just feels overcomplicated. So I'm still polishing this setup for my own benefit and sanity. But hopefully when this has finished doing what it's... I have no idea what's just triggered that, unless I accidentally unplugged the noodle by mistake. But I'm showing you this because it's painful, and I wish sidefx would show some kind of tutorials dedicated to this kind of workflow, like perhaps do a large emission of Vellum simulation or grain simulation or fluid simulation or something, and show the geometry clip sequence, how you deal with freshly generated data, or how you deal with an existing bunch of data on the stage that you bring into the SOP modify or whatever you need to use there, like a SOP create node, and then how you would bring this back out into a Solaris, into a USD structure. But this is how I've got it working for now. So I'll be back when this has finished doing what it's doing. What we have on the right coming up though is a very simplified version of this, so we can show you the concepts behind it. But this is kind of like the full setup for those renders I showed you before, which those renders, they were overnight renders, all of them. Like they set up at 6 in the evening, and then I picked them up at like 9 in the morning, and they were just finishing off, and they were only 720 HD. I just used Nuke to upscale it to HD, then I used DaVinci Resolve to knock it to 4K, and it kind of look a little bit mushy, but for tests and social media, I think it's fine. If it was proper client work, I'd probably consider doing it HD or trying to get it to 4K, but or even 2K and uprising to 4K. These, I'll be back when this is finished, because it's kind of a little bit of a slow process. All right, well, that came back as soon as I stopped recording, very typical. So that took about 5 minutes while I was waffling on. But what I did is I've cached this to disk, and it's now, whenever I load Houdini, it's going to load it from here and not touch this, because I think this would force it to look inside of here and try to cache it locally in RAM, expecting this to go to disk. So if I click on this, it's going to expect this all to go to that location I showed you. So what we end up with now is this with, well, we have everything we need, but it doesn't have any materials at this stage. I don't believe the materials are assigned in here. I don't think we have any materials. So if I just run an XPU on this, and there might be a way of doing this within in the SOP network here. but I would imagine it's just going to have the geometry color in the viewport. Yeah, so as you can see, we don't have any materials in here at the moment. But if I sublayer this in now, and we can now actually see the camera, and the camera's like, it's wrong because I've got a camera in here that I basically started doing all different tests and just use one camera. So I could edit the camera here, I guess, or whatever. But for the sake of this, there's no materials on these guys at the moment. So what I would do is I would just assign the material here and essentially assigned everything back on like so. So there is materials within this USD asset. They just seem to, the new geometry that we generated didn't have any kind of paths generated in here. So the original geometry that we had, the three geometries, I think the hidden ones would probably have a material on them. You can see in there it's got a material. So again, I then decided to do like a randomization. So I varied like the assignments of all the geometry, because each material has 3 different variants. So I just randomized that a little bit in here, like so, using this vary material assignment node. So again, it was interesting, but it didn't change the viewport, but it did, because I think I'm only randomizing the render. If I put a star there, it would randomize the proxy in the viewport as well, but I think it would treat that as a separate primitive. So this render geometry and this proxy wouldn't get the same assignment. So I didn't figure that one out. But essentially that's going to randomize the, for geometry for this GeoA monster, it's going to choose between those 3 and just randomize. So we don't just have 3 materials, we'll have like a different material for each one, slight variation. So that depending on what you've got in your USD asset, you can load and randomize loads in here. So that was just like a last minute thing, but I didn't really spot the problem of the viewport, the proxy geometry representation, not getting the randomization. So if I turn that off, there's no change. But if we, oh, it's so fiddly in here. If we go to the material, we look at one of the guys in here, geometry for the render. Let me expand this. Ooh, it's getting 1 assignment, but as soon as I switch on a randomization, for the what did I request? The Monster A Geo render skin. So I haven't done the fascia. So if we just look at the Monster A render skin, you'll see the randomizations happening. That's not right. Skin, maybe I need to do an O here. Have a look. Oh, there we go, that's fixed that. So that's kind of randomized that. And then we can do the same here. So we can just randomize from that and that. So now all the skin is getting a slightly different material, like so. So it was just an extra thing that I was just figuring out. So B should have a different skin if we take a look at that guy as well. So let's have a look. Not the proxy, but the can get quite fiddly. It's not a late night job, this. So let's have a look. Yeah, so that's getting randomized between 1, 2, and 3. But I'm not randomizing the fascia because the inside, you may have seen that red thing inside, which is just for subsurface, and it's just to give it some thickness and an inside piece of geometry just for fun. I'm not randomizing that just yet. I don't need to, so I'm not going to try and work it out. So hopefully now we've got randomization, then we can stick a light in there, and then I can define a render range here as well. And whatever I do here now will update. So I could just test render whatever I want, 10, 50, and this will update. So, but it won't change. If you come back up here, it will change again to the simulation range. So I'm just kind of using these to kind of set this range, just while I'm experimenting. So I'm kind of like sandboxing stuff here. It's not really a traditional VFX shot workflow, but it's a quick way of trying to figure out how you would get, like, how do I get these, you know, this lineup? How can I choose those three, in this case, these guys, and then do some stuff with it, and then get that back in with some material assignments on, and then just render that, and then stick a camera in there and do what we need to do. You can edit a camera and you'll get like the setup in here. So the camera's changed, like I said, because it's not, I didn't really mess around with it too much, but the actual interactivity is quite nice now. And when you render this, hopefully it won't crash, but this will render correctly. And if you're into the rendering part, I'll talk about that in a separate video. I'll just go back into this nitty-gritty part here. So this is kind of like me trying to show an overview of like how I did things. So all of this is just other versions of the simulation and more efficient ways of doing stuff as well. So this is quite a big file. I think these bits of geometry could have been optimized a lot more as well. The topology was quite heavy on them, and I think we could have halved the topology and stuff. So what we're going to see here is the AOV is going to come through, and it's going to be the occlusion AOV because of the way I've set this up in here. But don't worry, you can literally just go to color and it will show the color coming through. So I've just got this kind of background on there. So that has to load all this in. Now these materials and textures are all defined in the original USD. So I haven't added anything. I'm just using what's there already in the asset. The idea is just to generate more of them and get it into a hierarchy, which is a nice little hierarchy in there, I guess. Like so. So what we'll do next, we'll just take a look at what I did in here. We're not going to go too much in Vellum, and we'll just skim through quite a lot of it. But the important stuff is what you do with the output geometry and how the path and the name is important to get that within the proxy and the render in the right place as well. So if this highlighting is bothering you, it's because we're selecting stuff in here. I think you can turn that off like so. I think eventually we have render settings on here. Oh, this is a digital asset I've made. It's nothing special. It's just so I can go in and kind of configure a few different passes. In fact, I think the asset is simple, really. It's just that with a top network to kind of do a couple of dependencies. So it's the same thing. I just drop things into digital assets. I don't really use digital assets like with tons of parameters because I'm forever going in and tweaking stuff. So I just drop it down as a way of just bringing a collection of nodes, like a workflow together. But it's a very generic kind of setup thing going off in there. And occasionally I'll promote an obvious thing. So this is kind of loaded in now. It's quite a tough render, this one. But you can see they're all motion blurred and they're falling in there and stuff. That's what we see in the render. So before my machine dies, because this was like, it was quite heavy, we'll go inside and we'll take a look at what I've done in here. Okay, so before we delve into the SOP modify, I just colored these nodes blue to represent like a USD workflow. So purple is my CFX color. So nothing really there. So as you remember, we have this very interactive, almost 25 frames per second. In fact, you'll see it's stuttering a little bit, but once it's kind of gone through once, Houdini will cache this, and then it will be almost, well, it'll be quicker than real time. If I, like you can see, if I take off the real time toggle, it's really quick. And that's going to be quite nice, isn't it, for like lighting and interacting with. So that's kind of really worth it as well to have this proxy in the viewport. So don't forget we're viewing the proxy here. I don't want to switch to render because that'll well, it's going to load a lot of heavy geometry in. So this is what these proxy things are for here. So we're going to dive in to the setup in here. So I've got a SOP modify. So the primitives I want to bring in here of modulus assets is referring to this asset collection here. So it's just going to bring these in. So it doesn't really matter what you feed into this here. It's just going to bring in these. So they're going to be up for, well, you'll see what I mean. It's going to bring in frame 950 here. And I'm going to bring in the proxy and the render, and I'm going to unpack the USD primitives to polygons to start with. So that's all we're going to talk about at the moment for the export it to SOPs. So when we export it to SOPs now, we go in. So we'll go up to the top. Now there are many different ways of doing what I'm about to do. In fact, I'll show a few different ways in a few of the other examples to the right of the one above you just saw. So meaning this down here. So I'll go in there and I will come up to the top now. So if you press U, we are inside of this monster mult CFX01. So when we go inside, you'll see we're in this monster mult and this subnetwork modify, which is the SOP modifies digital assets sidefx's tool for helping you get stuff done. So when we bring this in now, you'll be faced with what you've asked it for. Okay, so we've just got 3 assets in here. So let's just hide all, and we'll just go to primitive and we'll hide everything here. Whoops, didn't quite get that. Then we'll probably just bring in the path, maybe the name, just to keep that open for now. So you'll see that we've got everything we need, and that's going to be quite useful. So I'm going to just set this to rest position. So it's just going to align everything. Now the models, there's 3 models, but you can see the head of the other one poking through like so. So if we do let's just do a align and distribute along here, you'll see by connectivity or by path attribute, you'll see the different paths for the three. You've got a render geometry here, and you've got your proxy geometry, all like ready for you to play with. So the idea is we want to create simulation geometry for, in our case, just for these 3. We're going to take the render geometry and deform that, the fascia inside. We're going to send that back out to Solaris for lighting because it is a major part of it. And we're going to deform these guys, these monsters with Vellum, and these are going to come along for the ride, and then so are these proxies are going to come along for the ride, and we're not going to touch them. So the first thing I was doing is I just poly reduced at this stage here everything to do with the geo render skin and the fascia render skin. I just poly reduced them a little bit just to see whether I could get away with it, rather, because I didn't have any poly reduced lodded versions in Solaris and the USD, so I just did it here to see whether that would be okay. It seems to be fine. So this is just doing the render geometry. So again, now if you look at the alignment, we'll have a slightly poly reduced version of both the fascia and the skin. Not a great deal if it's actually coming through. You see that just changing a little bit. I don't know if you can see that here as well. It's very subtle, but it's just There we go. So it's just poly reducing them a little bit. And that was just a last minute thing. So what I want to do is I want to create a simulation geometry for each one of these. I'm going to do this separately. Now, I know it's Houdini, and I know we could have one set up to loop through this, this, and this, but I wanted to kind of create a sim mesh for each one. So if you want a tutorial where it loops through, we'll do that. And you may notice that we go ahead and we simulate, and then we point deform each one separately as well. In the other tutorial that I do, we just use one system to loop through, and there's advantages, disadvantages for doing either one. It depends the project needs really. So in this case, I decided I wanted to treat each piece here. So remember this on the right here with my mouse this is the render geometry. I'm going to use that to generate a simulation mesh for Vellum. And that'll be the thing that we throw around and we emit, or we create a copy of these in a scattered kind of emission source. So I'm going to go in here and I'm going to get the geo. I'm going to go ahead and I'm going to grab geometry A. So what that does is grabs the render and the proxy for our friend, the A model. And then we go down and we split the purpose. So now we'll split the render geometry here. And we have a clean version of the render geometry. And then we'll have the proxy version here as well, nicely organized. And then it's rinse and repeat. So I do the same. I get the opposite of this, so that will contain B and C, and grab model B, it's this guy, and we do the same here and here like that. And then finally we grab monster C and we do the same where so if you ever look now, we've got like, oopsie, if we go in there, you've got the render, and then here you've got the proxy, and so on and so forth. So we're just kind of splitting out a bunch of data, right, from this one file. So that's quite interesting, nice and tidy. So if you do change things, just be aware, and just, you know, you'll have to manually copy it. I mean, these are just direct copies. These three networks here are direct copies, and you could loop them, but I don't want to loop them at the moment. So the next thing, we kind of bring down this section. If you remember, this is the render geometry. We'll use model A as our example. And I just want to get just the skin. So I did actually have a group called skin. If you look in there, and if we blast away, we'll just get the skin geometry, which is these two colors here. So it's like a thickness to it. So we've colored the inside this, and so there's kind of a lot of fat in there. And then the red one inside was the fascia, you know, which we saw earlier, which was this guy. And then just because I want to keep this Vellum simulation really quick and easy, I'm going to make this like a volume, a really thick volume. So I'm not really considering the fat and all the layers and stuff. So I'm going to just get the inside group and delete it. So now we've left with a shell of the render geometry. And then I have this digital asset, which is doing, I'll just hold this to manual. So this digital asset will produce if I can quickly have one I made earlier, will produce a tetrahedral mesh like so. And that's the geometry. And I've got an unlocked one where I've just made a lower res version as well. So if I quickly go in here, and you'll notice there is a save and a geometry file, and it's kind of linking to this asset version, which is just linking to here. And again, you might see this is going to create a unique piece of data based on this node. So we can have as many of these SOP modify nodes, and we can do what we like, and we can have unique sim geometry for each one of these. So that should be rather good. So I'm going to jump in here and just quickly talk through this. It's a bit overkill, but it's just a digital asset that I use for just getting some stuff done, and I strip this out as of when I need it. So if we come back up here, we go auto update. It brings in this, and then we're going to subdivide this. and then we're going to do a polyfill, and this is going to make sure that any gaps, now there are no gaps, it's going to complain, you know, the no patches were empty, and that's mainly because sometimes you get bad geometries. It's just to remind me. So in a way, we don't need that at the moment. So we're going to create a VDB from polygons. It's quite dense. I'm going to do a reshape, and then we're going to convert this back to polygons, like so. I'm going to add some normals, and then I'm going to blur the normals a little bit, and then I'm going to do a soft peak. So I'm just going to peak this out, and the blurring the normals is a nice way of averaging out the normals so that really sharp edges, when you do a soft peak and you swell this out a little bit, it just evenly goes out nicely and it doesn't fold in on itself. But this is very subtle. This is very helpful later on, just kind of push and pull volume, just kind of help with the displacement and render time and things. So I'm going to create an attribute called thickness, which is not the most efficient workflow, but it's going to create a normalized thickness value so we can view this guy with the visualizers here. So if you click on that and we go down here, and we got like the thickness, and then I'm going to blur the thickness out. And then I'm going to create an attribute called target mesh size. I'm going to take the thickness and rename it to target mesh size. Now this attribute target mesh size is used within the skin, within the remesher. So I'm going to blur the target mesh size a little bit, just kind of, and what I'm essentially going to do is in the remesh node, I'm just going to put more resolution here in these darker areas. So I'll get more fidelity in the simulation and also get more points for precise collisions. And for when we use these points in the point deform to deform the render geometry, there'll be a good relationship between them. So this remeshing part can be a little bit slow. You only have to, I bake this down afterwards. So I'll show you what I've done here. Now, this is just one way of doing it. There are many different ways, and different monsters and creatures and simulation geometry can often require different setups. So this is the low res version for getting stuff done for me, right? So it's not perfect, but it's going to be good enough for now, right? And then bring in the original, and I just ray that back on, and it just makes sure it goes back in. It kind of just helps a little bit. I didn't use any of this. This is a bit here in this setup. I've shown this in the previous tutorials making monsters in Houdini. You can actually add more resolution inside the tetrahedrons as well by giving more points. So then we'll create a tech conform, and we can add the surface triangles. And when you add the surface triangles, it's going to create some groups, surface triangles, interior points, surface points. So I put it through this system here to basically give this a name, and then group any, I delete any unused groups, and then create a temp name. And then I use this little trick here to take these interior points and I rename them like this. So what we essentially end up with is just a clean set of groups. We didn't really use these in the end, but it's easy to identify the groups in a much larger scenario, I guess. And then I'm going to clean up any unused attributes in this case and do an attribute copy and just make sure I've got a path back on. Again, not particularly useful, but sometimes quite useful for quite complicated setups. So we're going to establish a new rest on our tetrahedral mesh. Again, it's very low res because the thing I skipped over is this guy. It's using that target mesh size and a gradation and a relative density, and I'm basically just using that for now just to kind of get what I need. So, and that's just a very cheap way of getting a sim mesh out. Not the most precise mesh, but for some of my smaller simulations, I have a better simulation geometry. And in fact, you could load your simulation geometries and, you know, have like different simulations for different distances and stuff if you were doing like swarms and things. So this gets baked down to disk and that gets saved to a unique location. So the long story short, this is what this is doing. So it's kind of creating these simulation meshes. So whatever you've learned here, we're just doing the same here and here. And then I just color it, create a group called velocity group. Something feels slightly off about that though. Let me just check that. Yeah, something feels wrong about that. Like I feel like, oh no, that is correct. Yeah. I was just going to use this group to put velocity and forces and stuff around on this guy, but you can create as many groups as you want at this point. So I actually used the inverse of that, and I used the tips. You see the tips are not selected, and I used that to kind of play around with some forces and stuff later on, but that's just trial and error. So I'll show you that in a second. It's not critical to the tutorial. So then we keep this really simple, and I've just created a tetrahedral stretch constraint. So it is literally one tetrahedral stretch constraint on here. Then I'm going to pack this like so. And I do the same for each one, like so. So you just end up with packed vellum geometry like that. So it looks a bit crazy because it's all overlaid like so. And then I'm going to put this into an emitter setup. And again, you can see I don't have many going off in here. And this is just another network for just emitting. So I'll not go through this. You can take a look at this, but well, I will. It's really basic. It's a grid, and then I'm just going to copy that. And this is just randomization. I give it a normal, and then I'm going to do a frame hold, which isn't really important in this case because my source is not animated. I'm going to scatter some points on, create a rest position for those points, attribute interpolate, and a p-scale, which I'm going to leave at 1. And then I'm going to create some spinning attributes, and I'm going to relax those points. I don't think that's really necessary. I'm going to add some velocity, and then all I'm doing here is just culling the pile. I'm not emitting. I'm just going to take this, and there's easier ways of doing this. I'm just reusing the workflow, but essentially I'm thinning off the top and the bottom to get like a feathering going off, and then I'm just moving them up a little bit. Then I'm going to use an attribute from pieces with a variant. So the variant is basically going to create a variant name like so, using the enumerate. So I'm going to say I want like the geometry and the constraints to come together. So that's really important that they belong together. So this patch A, or it could be monster A, I guess I should have named that sensibly. It's going to then convert that to a point attribute, and then just rotate that 90 degrees for instancing. Probably spelled that wrong. And then we've got a cleanup of attributes we don't need, and then we've got a temporary cull. So when we're deving stuff, I can call this based on the ID. So if we copy this now, what you end up with is you have vellum geometry and vellum constraints ready to just drop, so or emit. In our case, we're just going to drop them. So if we now come back up like so, we can do a vellum unpack here like so. When we bring back these two attributes if we want, we can create a geometry, and then you'll see the constraints, and we can randomize the density a little bit. We can randomize the friction, and then we can put this into a vellum simulation. So let's just keep it nice and quick. I'm going to make sure that starts at 950. Also, back in the, when you're doing simulation, check you're on 25 frames, and you want to make sure that matches what you're declaring in Solaris in the USD. So I think I did that in here. So back in there, we can start to look at the solver, and the solver's got a few things. This has not been used, but we've got a rest blend, pop wind, pop axis, and then we've got some popper tracks, which is pointing to this CFX star V group, and this is pointing to the same group. So this is the inverse of that group, and there's just a bunch of things animated. So this is not really important for the tutorial, so I won't go over it, but I will go over the rest blend in just a second. So what's going to happen is they're just going to spin around because the points have got a spin attribute on them, a W attribute and a velocity attribute, spinning them around. The viewport's going to freak out a little bit, so you see how they're not falling here. Well, they don't exist. You have to go labs, reset the viewport. Oh dear. Like so. And then we can just have them like spin and fall. I'll just let it simulate to show you the speed. In fact, we'll not go any further than this in terms of resolution, in terms of the amount of objects. Because the point is just to take those 3 USD geometry variants, make loads of them, deform them with Vellum constraints, get them out of Houdini's SOP modify and back into a USD structure. And I tried to do something about 2 years ago when I first opened up Houdini to go into Solaris. I did something with love hearts, and I was overwhelmed by the component, but I was overwhelmed by USD. I knew how to do all the stuff traditionally, but I was just like, oh, well, I want to generate a ton of these things procedurally, and then I want to get them out efficiently, and I just felt a little bit overwhelmed with it all. So I've just been kind of chewing away at a few setups to try and get that done. So you don't have to use monsters. This could be used for anything, I guess, and you don't have to use this setup. So there they are. So they're probably not all going to fall to the floor because the frame range is pretty long. It's pretty short. So, but what eventually happens is the actual Vellum sim, the pop wind, I'm just creating a bit of air resistance. Then I'm doing a pop axis force, which activates at a certain time. And I'm just animating, just keyframing, shift to get these, just kind of bring in some spins and some weird stuff. And then these arms and these popper tracks are just pulling a part of the geometry around a little bit. So those groups that I'm referring to here are those yellow groups in here. So it's this. So it's kind of like just a force is going to be applied to everything but the tentacles. And so you can create as many of these groups as you want, and it will feed into Vellum. Then you can access them in Vellum and change things around. So we essentially have a simulation, which is, you know, I'm not going to go into the simulation workflow too much. If you jump inside, sometimes you don't see the simulation. It's a bit weird, and you sometimes want to see the simulation. So I've found that I have to press U, lock this off, and then go in, and I can play around with, you know, this is cached, by the way, because it's blue, but I can kind of play around with this, and then we'll be able to see the full range. So temporarily, we're going to just set this to, should we set this to 200 and just show you the kind of the simulation messing around with it. And that's what all those other versions are. They're just different variations of forces and things just playing around, but the concept behind it is the same. The only thing I change in the other versions of this system, these SOP create nodes or SOP modify nodes, the only thing I change is the output, where I don't individually wrap things. I loop through. So we'll let that run. Here we go. And I'll be back when it's simulated. And you can see it's not too painful. I think to do those large simulations on this resolution of mesh did take, actually on the settings you see, did take about half an hour or something. And of course, if you have heavier resolution meshes and You're going to have to wait longer, but it would look kind of cool and be more precise. It depends what you need. But to get like to kind of block through everything, this is fine. That's why I've got two of these digital assets you saw in the network above, the high res tetrahedral mesh and the low res one. Just boink. So yeah, so they're kind of gonna spin around and do their thing, and you see how the arms are being lifted. That's because these arms are using the inverse group, so they're going to get pulled up, and it looks a bit creepy. That's why I did it. There's loads of stuff you can do with the actual simulation stage. It's Houdini, and I didn't even need to do any of this. I could have just dropped them and carried on, but I figured it looked pretty boring. So I just like threw something really quickly and then just went with it to try and make this tutorial so I can remember what I did in 6 months' time. So hopefully now, we didn't wait too long for this simulation. So you'll see these guys falling. There they go. And I'll just go into wireframe. Sorry, smooth shaded. So they bounce along and they kind of congress to this central point, which is the body. It's been pulled in and the arms are being animated. The force on the arms, on the tips of these tentacles, should I say, are being pulled up and you're getting this weird spinny thing. Right, so that's what we've got. We might as well leave that frame range here just to show you what we need to deal with. We're going to go up. Then you do your usual thing where you clear out any attributes you don't want, but it's just a simulation geometry. So I like to get that done here so I don't bake them to disk, and I remove any unused groups and I convert this back. So if we space G, now we've got like just the simulation geometry rather than having the tetrahedral stuff inside. Sometimes that can help with point deformation, but I'm just going to get rid of it for simplicity. So I'm going to go ahead now and then just save this out. So that's all going to a unique place like we did before. It's going to go into a unique folder dedicated to this. Let me press U. Dedicated to this setup here. So it's always going to have a folder and we know it's part of this setup. Same with the simulation geometry. It's kind of unique to this network. So let's just blow through that, get this on disk. All right, so now we've got a cached simulation that's really quick. Oops, yeah, not many of them, right? So, and then I'm going to create this connectivity node called class, and then I'm going to grab the original for each one. I'm going to grab the original. I'm going to do these. Oh, I've not talked about the rest blend. To be honest, you might not notice, but the geometries are like pulsating a little bit. You see, you just can't quite see it, but they're like actually pulsating. So that's the rest blend constraint in here. So it's going to be set to each frame, and I'm taking the constraint group from the stretch vellum tetrahedral. So press U. That is actually referring to this stretch constraint underscore tetrahedral. So a middle click, it's because I've got a vellum constraint for each model, and that's the advantage. You can kind of tailor a few things here separately if you want as well. So, and those groups again for the V group, you'll notice I'm being used in here. So you can make as many groups, and you can see there's that group being starred. So I'm bringing them all in, and then this entry point here, if I just click on it, it takes me to, well, it takes me to this setup here. So all I did was bring in the render skin geometry. It's coming from here, so it's bringing in this geometry, and then I'm just going to hold that frame, and then I'm going to create a ball. I'm going to bring in the points from inside of this guy. So I'm going to get the points, and I'm going to copy a sphere onto the thing here like that. So it kind of matches these guys like so. I'm going to create an attribute called grow. which is a noise attribute, is animated. So if we click on the points here, we go hide all and we go grow, you'll see if it goes from 0 to 1, it's just kind of going from 0 to 1 and it's a noise. So what that's going to do is we are going to have animation on these things, but it's not really important at the moment. We're going to transfer an attribute called grow onto the geometry. So we should now see the grow attribute on here doing this kind of nonsense. Then we're just going to blur that out a bit so you get this kind of weird thing. Very rushed, I'm afraid. I'm going to use a for each loop, and I'm going to animate each one basically pulsating with a sine wave, so it will animate at a certain frame and it'll just pulsate, and then I'm going to blend shape that in over time and then point mix this on so we get this for each one like that. So that's going to use the grow attribute. So we're going to go through this for each loop. It might be a little bit overkill, but you get this kind of like pulsating rest blend thing going off. So if I take that off and I go into here and you press play, you'll see you get this. So you can cache, this takes a bit of a hit, so you can actually cache this out, so you can kind of get a rest shape that gives you a pulsating thing. So that's going to be used in the Vellum sim. It's optional. Again, it's really not going to help with understanding geometry clip sequence, but it's just coming in there. And then we simulate that and we cache it, as you see. So then you get this bunch of things, and they are actually pulsating, so you can just see them, and it's just for fun. So the next thing we do is we split, and we start splitting out, and I'm using the pack 01, very stupidly named, but I gave each pack a name by doing this, so I can split out each one like that, and I can give each one a unique setup for like point deformation. So there they are. There's only one of those guys. So this patch A comes in like so, and ooh, I don't need that anymore. Let me just delete that. Let me just check. We don't need that anymore. Yeah, I'm poly reducing up here now, so that can kind of happen at any point. So we're going to bring in the render geometry at the origin for geometry A. We're going to bring in proxy geometry. I'm going to put some normals on this so it looks a bit nicer. And then I'm going to do a for each based on the connectivity primitive. So in here, it's got two kind of flow sections. There's the render geometry and the proxy geometry. So I'm going to take the sim mesh and put it to the rest position. And I'm going to take the first connected piece of this guy and the rest position. A point deform takes an object to deform, a rest position, and then a animated position. I'm going to point deform that with some values that just worked. I'm going to transfer the velocity over, and then I'm going to add a path. So I've set up a little thing here which will allow me to take this and just call it this like that. So that's all I've done here. And then I do exactly the same for the proxy geometry as well. So we've got a click on that guy, proxy, and I merge them together. And why do I split them back out again? I split them into render and into proxy. There's a reason for it. It's a bit overkill, this bit, but we rinse and repeat. So we end up with the same for model B. And they've got render and proxy. We've got render and proxy, and all of the proxy go in here. So I can take a look at the proxy geometry that I'm going to save out. There they are. You may notice I decided to ditch the insides. If you look at the render geometry, we have everything we need, but we've got a slightly reduced model now because we reduced that kind of just before we did all the work, I guess. We don't need to do that, but you know. So we've got the fascia comes along for the ride as well, this red thing. I don't know if you can see that red thing in there. So where was I? We've got the proxies for the viewport, and we've got the render. So the proxies, you're going to have to play around with individual things here to kind of get this looking right. So you might have the render geometry, and you want to be looking at the original sim geometry to see if that kind of aligns up here, like so. And then you've got this geometry here. So the problem with that is probably some settings have been set on here which are just wrong. Can't remember. Maybe it's too much. 0.1 maybe. But it's proxy, so it's you can tidy this up as much as you want, but it's just for the viewport. So I kind of did that, and maybe space G, just quickly sanity check these against the simulation. That seems a bit better. Maybe I was experimenting on that one. And then 0.1. So yeah, so we have the render geometry coming in. Let's go to the last frame. It'd be easy to gather everybody together like this. Got the render geometry, and this is the part where you call it post-sim finaling. So I'm really throwing this through very dirtily for the point of just getting something out into Solaris. So we've got 3 unique setups, which each kind of treats the render and the proxy for each asset or each geometry variant. So if we just take a look at the sim, it kind of closely represents the simulation geometry as well. And then we have the proxy for the viewport. And the proxy coming in is the original proxy. So the only thing we've changed is the name. We've added skin _ 0 and 1, and we've kind of done that. So the optional thing here is, I don't know if it's actually doing anything anymore. It's kind of an old setup. The proxy geometry from Solaris does contain like an inside and a fascia. So I just blew that away because I don't, it's just going to be a bit more efficient not to have that data, and it's just my choice to blow that away. So I kind of did it individually on each one there. We can also just globally do it here. So you bring it in and you end up with this like quite messy, like overlaid render and proxy geometry. Then I set this transform by attribute. I set this USDX form, which will shift this out of in the wrong position, but when this is baked out, it'll be in the correct place in Solaris. Then I set that kind of USD frame samples we talked about that we would have to add on to the end of the geometry clip sequence if we didn't do this. And then I've set this USD visibility because it's going to make all these guys visible because they came in set to invisible, so that if I wanted to view outside of Solaris, I'm not going to see the original guys. I'm just going to see whatever else is there, just optional. And then it's a case of writing all these to disk. So you can see we had a lot before. So going to save over, I don't care, I'm not going to render that again. I'm just going to save over these. So this could take a bit of time, but you have to deliver something, right? That's the render geometry. And this bit can take a bit of time because you might be doing finaling work in there and whatever you need to do. So that's going to bake out. I'll be back when that's done. All right, so we've got the cached geometry out. So we've not changed anything in terms of, we've not added any additional attributes. We've just changed the path basically. So let's see what we get if we press up. Let's just double check. Where's the geometry? Oh yeah, let's bring this back to the stage. Just make sure that's linked, then we'll get the right thing here. So proxies there, proxies there. Let's just expand. I'm going to just try to make heads or tails of this. So look. Yeah, I think that's right. We just have 2 for each. Yeah, so it's kind of correct, I think. Yeah. Wait a sec. Proxy there. Yeah, that's right. So the what you're seeing here is geometry A. You're seeing the original geometry here that we've hidden. You'll notice in the little eyeball thing it's hidden. So we don't want to see that because it would just be sat at the origin. And then the rest is the new data for the proxy. We don't need the inside because it's just of the viewport, right? But then for the render, we do have an accompanying fascia and skin, and so that's quite nice. So if we do switch this over, hopefully my machine can handle this bit. If we set this to final render, you'll get the render geometry point deformed, and you'll be able to see, in our case, if we just go into we'll just pick one and we're going to isolate. Pretend I know what I'm doing. Yeah, no, I don't. Where do I reset all overrides? I keep changing the way things. I've just got used to things, and then they've changed all the icons and stuff. So maybe if I select this and we go into subcomponents, leaf maybe. Yeah, so I can grab individual ones, and I think there's an isolate functionality there. So yeah. And we should be able to see the inside as well, the red thing inside, which if we just go to isolate, you'll see that's there. That's point deformed as well. I do need to work on because I probably reduced this, it's probably not the nicest point deformation. Topology is really important when it comes to that as well. So, but for the point of this is we've got something now in a hierarchy that we could potentially use. So this now goes, directly into here, and we are going to just cache out, even though we've simulated this amount here, as soon as I look at this, it's going to go back to, if this is enabled, it's going to go back to that 1000. So it's up to me if I want to cache the full if I want to bake out the full frame range here, I can do that. For the sake of this tutorial, I'm going to just hit this. I'm going to hit render here, and this could take a little bit more time, I guess. Now, if I can figure out a way of doing this without, well, I don't know if there is another way. There probably is. But it just feels like this is another step that we never had to deal with. Even like getting the proxy stuff out for viewport, it just seems like an additional thing that we never had to really bother about. But it's kind of, once it's in place, it's not too painful, I guess. Now, we don't have much geometry, so this is caching. It's basically saving new geometry out into this geometry clip sequence, and then we'll get this that we can utilize. This top network is just a way of just running everything in this little environment here. So let this do its thing. All right, so that's now, the geometry clip sequence has now kind of been cached, and it's really quick. And that's what the long wait was for here. But it's also been, this has all been saved to disk, and this is referencing this stuff on disk, and then I'm going to sublayer everything else. I'm going to sublayer that back on. So we get like, we can actually look at the camera and everything like that. This top network was just specifically for this and this node here. So it's referencing DC Sim and DC Remesh and Monster Cache. So these two belong, if I've got this right, belong to the belong in here. So if I click on that, that should be belonging to what's in here. So if I click on that, and I may have got this wrong, I should really stop changing things. Monster Mult CFX or 1. Anyway, let's fix that. So this remesh, I can copy that, press U, and then I could go in here and paste that in there like so, and then click on that and get a relative path. Now if I control click, that's going to activate that. If I control 1 here, then I press U, and I go in there and I control 2, then I go to the sim geometry. Where did he live? I can copy that and then press 1 and click on that and go paste and get a relative path for that, and then control to check. That's all set up. So it's going to run the sim and the remesh. I'll do the tetrahedral generation manually for now, but the things you iterate on is the sim and the remeshing. You might be wanting to do that. Then when that's done, it's going to run this cache node here. If I press U, it's going to run this. So if I run this now, it's going to run the simulation, and just basically it's going to have all this ready for me. So that's just another kind of semi-automated thing going off there. So you get this proxy representation now of your simulation. So I might have done overkill in here, but I've done it like this because I can copy and paste this, and all the simulation geometry and all of the sim stuff in here is a brand new system that can be kind of utilized and read in. So we've got another one here which you can, it's just a copy, but you can iterate and you can debug and do what you want in there. So that's just what I've done here. So there's just another version of that. Nothing really, it's just a copy. But you'd want to copy like the whole system, I guess, over. Then you could start iterating more versions. So that's kind of what I've done over here. So there's just like different scenarios. So let me refresh my memory. If we bring in the USD hierarchy again here, again, I could just plug this in to like here and here, but I'm just plugging this here to fetch this kind of this network over here, and I'm setting a frame range again. So I have now essentially got like another frame range. It's almost like another shot. If you change the frame range, you could add another camera, but I'm just sandboxing stuff. So I then created this, used the same settings, and went in and I just did some stuff in here. And this time it's a Vellum sim again. I can't remember what the Vellum sim looks like. Is it a large sim? It could be just a slightly different version where something seems a little slower than it needs to be. Let me just make sure I'm... Yeah, so they're all just like in zero gravity and then just flying around. So it's just what you want to do. The point of it really is getting it out of Houdini world back into Solaris. So in this case, this little network is responsible for taking all of these and wrapping them. So I brought in the render geometry. Like so. This is not emitted, by the way, it's just... So I brought in the render geometry, and I've done things a slightly different way on the input here. So I brought in the 3 guys we need, and I did some poly reduction on the skin and the fascia. I then proceeded to go through, and I've got a slightly higher res mesh here, look, because I'm just playing with this with few of them. So it's the same setup. Now bring in all of the render meshes here and here and here. I bring in all of the proxy geometry here, and then I bring in all the sim geometries. And what I decided to do is merge those together and create an attribute called GeoID, which is a point attribute. So if I come over to here and I go GeoID, we can just identify everything that belongs to A, B, and C. And then I'm also doing the same. What did I do here? I think these guys add a name attribute, and I just changed the name attribute here. I just did this. So I basically got GeoID, so they can join in with these. So if I add them in, the whole bunch gets the correct geo kind of ID, ABC, like that. So I'm going to use that inside of this network here. So what I'm doing here is I'm bringing in, and I'm taking the geo ID, and I'm just making a just a count, so you can see like GeoB here is the sim geo, and it's 1, and then GeoB here is 1. So the variant PT point attribute is kind of being enumerated via these values. And then I'm going to convert that from the original point thing to a primitive, and I'm just going to basically make that a primitive attribute called variant, so that when I use the attribute from pieces, I can copy everything in here. So you've got like the rendered proxy and the sim geometry and the constraints all in the right starting position. Yeah, so you can see the sim geometry, it's packed Vellum simulation geometry, as you can see. So there's the geometry and the constraints. You can see them here, like so. And you've got the geometry, render geometry, and then you've got the proxy geometry, and that sends out 3 nodes, which we split out here. Whoops. So of course the sim goes into the Vellum, and then we do the same stuff. We've just got a little bit of a change inside here because we've got some different fields, but it's pretty much the same. So I was just playing around. So we essentially, we didn't use any collider, but you could bring in colliders using this LOP path, and you could bring in the floor and set what you need from it and things if you want. We didn't use any colliders. We run the sim. We did the same as before, and we ended up with a cache like that. So we do have this. So what I decided to do is I bring in the render geometry and I time shift that to 950. Oopsie. And then that needs to get the same values, so we might as well copy that and paste relative references, because you want those to always match. So you've got that, and then you've got this. What is going off? Let me just make sure. Oh yeah, we're going to have to save this sim out. So it's, yeah, I think we might have changed some things. So the simulation position or the orientation was different to the start, I guess. All right, so 10 minutes later, we've simulated again. I think I accidentally switched over to the high res geometry, so it did take a little bit longer, but you know, it's the thing, isn't it? So if we take a look now, the time and these two match. So what we're going to do is, it's a bit messy, I do apologize. We're going to point deform everything. So I think the viewport may be showing geometry that shouldn't be seen. Let me check. Should see the pink guys. So if I go to the very last frame, what we simulated here, then we look at the simulation geometry. That's worked. So it's just point deformed. And I've used this attribute asset ID to try and let's see whether we had any more luck with this. But yeah, that's actually quite nice. That's exactly like how the model should be, where you've got the thickness and the fascia sitting inside there. And then we've done the same thing. So here I've brought in the proxy geometry. Like so, at the rest position, essentially, the rest position. And I'm going to take that back into Solaris, but I'm going to remove the inside of the skin and the fascia geometry, and then I'm going to point deform that into place, like so, for the viewport. Then I'm going to, on the render geometry, add the velocity back in, and then I'm going to promote this asset ID here, which we may have not spoken about, and then just create a new name and use the asset ID to add to the names, so you get unique names that way, and same for that way. So this asset ID in here. So the asset ID, I created this on the points. I felt that would be a better way. Here it is. So the asset ID is just going to basically give an ID for every single point, and it's going to go onto the attribute from pieces. We can delete any information we don't need. And when we copy this on, it should just copy over. And it was quite a helpful thing to have, because it's kind of there on everything. So it's a nice way of making sure you get the right piece. And that's where the asset ID came from. So you can have a look through that scene and pull that apart. That carries through here, and I don't delete it here either. So it's it carries through, and we can use the asset ID in the point piece attribute to kind of get this to point deform, 1 point deform for the render, 1 point deform for the proxy on all these different shapes. So the disadvantages for both methods that I showed you anyway. But again, we do the same thing. We bring in the render and we kind of bring in the purpose, and I merge them together. Again, I don't know if this is the most efficient way of loading in a much larger sequence. Maybe we could split these out a bit more. I'll have to experiment with it, but we're going to set the right space, add the frame samples, and then restore the visibility for USD. And then we'll bake this out, and we'll bake this out to disk. So we'll have a BGO sequence that contains our render geometry, our deforming render geometry. And then all I'm doing here is just testing the kind of the splitting of the geometry, and this is reading the old stuff anyway. So okay, so we have cached the simulation out, and we've got the all of the render bits, and then a proxy geometry. So the next thing is the slow part. We press U, and we're up in this bit now. So I'm going to fetch the source. If you remember, we're just fetching the hierarchy here, all of this down here. The geometry clip sequence, I'm going to quickly set this to manual, but it's referencing this path in here. So that's all it's doing. It's referencing this. And then we're going to save this out to disk. So this could take some time. Essentially what you're going to end up with is if I come and look at this now, you're going to end up with another version, right? And it's all got unique data on disk as well. So, but you can just plug in an experiment, or you can have different unique setups or whatever. So that was it really. The stuff on this side, I believe, was just a slightly heavier sim that I used before. So there was not really anything to it than that. The last thing I probably would need to show is like an emission type of workflow, which this would all be the same. So it's just about making sure you get the right attributes in there. So I'm not sure how useful that's been. I will clear this scene up a lot to basically allow you to look at it in a more kind of, well, just an easier way of looking at it, I guess. So this setup and this setup are identical. There's nothing to. I'm just basically changing the simulation settings inside of Vellum, and the forces and things, and the scattering kind of setups change a little bit in there as well. So I might just delete that as well. Not particularly precious about any of this. Now I have actually just, there we go. So it you know, you've got two simulations you can choose from. Let's just go back to automatic update. So you've got very simple stuff going off, but hopefully that's kind of how I did that work. And you can see I've got 3 different render and different camera settings here. So that's because I had different settings and I was just choosing between different cameras and stuff. So for example, when you look at this frame range here and you look through the camera, that's what we had. Then when I look through that camera, it was for a different thing, and I've just edited the camera. You can see that I've basically edited the camera here, and I've just set its aspect ratio to be more of a social media type thing, and you can just animate the cameras. So these are just different setups, so we don't even need that, to be honest. We could just so you could actually have, like, for the same thing, you could have this setup, and then you could like edit your camera and have another render and just do what you like, really. But we'll get into the rendering in the next one. I think before we finish this kind of workflow tips and tricks, I guess, we will just set up an emission setup as well. Maybe we'll use this kind of method. So yeah, so that's pretty much where we are with it. Yeah, hope some of that's been useful. If you're finding this tutorial useful, why not drop a like and let me know in the comments. And if you're interested in learning more Houdini, hit that subscribe button so you don't miss out on the next tutorial.